So now, we've been talking a lot in this part of the course, as where we drew the line before, about mitochondria and chloroplast. So I thought it might be cute to throw in a few slides about those. And so we see this here. This again summarizes years of work. But if you just were to look, for example, at the ATP synthase, so that's this guy right here. The rotor assembly that runs off a proton gradient. If this is how life really works, then you would expect the ATP synthase to be oriented in the right position, depending on where the protons are accumulating. You follow me? Because if the protons are higher on this side, again, they have to flow through the half channels, exit the other half channel. You follow me? And sure enough, that's where things are oriented. So it very much looks like that what we have in mitochondria and chloroplasts, not just from orientation, but looking at the sequencing of all the proteins that are involved in these processes, not just the ATP synthase. But this first arose in bacteria. Thank you, bacteria. They came up with this scenario, and it got passed along into these organelles that we have as higher eukaryotic cells. That's pretty mind-blowing to put everything together and go, yes, every time you put the pieces together, they better add up. So when we ask the question, how can this possibly occur? Well, I found this timeline here in Leninger. And again, this is a rough timeline with more years of research. Things to be filled in. But over here on the y-axis, this is millions of years, which is, I think, beyond most of our comprehension. Okay? So let's take 500 million years. So try and put 500 little divisions here between 0 and 500. So man is up here barely on the scale, because the best archaeological evidence indicates that humans are about 200,000 years old. So, if you look at it that way, wow, back here, you've got bacteria, then you've got photosynthetic cyanobacteria. Imagine how many bacteria there are, because they can double within 30 minutes to an hour. So my point is, you have got an unbelievable time frame here for mutation and selection. Because the selection process is going to go infinitely faster than just you and I being mutated. Follow me? Because our age is, what, 80 years or something like that? These bacteria are going like this. Now, of course, there's been some really bad things that have occurred during this evolution, and life almost got extinguished several times. My point is, something that would be very rare, given enough time, statistically has a chance. Okay? So we kind of think that that's what's happening. Thank you, bacteria. And again, the bacteria are still most of what's on in terms of cells on this planet. Yep. So we think this endosymbiotic thing, you can read about this, we think this is what has occurred. Again, with each passing year, it seems more and more like this is really what happened. First summary. We covered a lot of material. That's an understatement. But I think at this point in the course, you can appreciate, first of all, we learned a bunch of pathways. Again, left hand, glycolysis, right hand, Krebs cycle. You should really know those. Why? They turn up again and again. You see the glycolysis part of photosynthesis. You should could also see how they interrelate with each other. For example, we said the last 3 steps of the Krebs cycle was like the first 3 steps of beta oxidation. We keep seeing how the Q cycle, that's in complex 3 of mitochondria, shows up in photosynthesis, in cytochrome P6F complex. Life finds things and tweaks them. Proton gradients are the name of the game. This is how most things get accomplished in terms of producing ATP and moving other things across membranes. We have looked at a lot of electrical circuits. It doesn't mean that we fully comprehend them because, again, the protons are hopping in many cases. The electrons are moving in waves. That's very challenging. There's a lot of research still to be done. Metals, my goodness. We keep coming up with metals all the time. They play important roles. They're not more important than carbon and oxygen because they provide certain chemistries, and together sometimes they provide special chemistry, such as at the binuclear sites in complex 4, or in the chlorophyll dimers in photosynthesis. Lastly, proteins. You study proteins in BIS 102 because when you look at all these things that we've discussed, none of them are possible if you don't have 2 things. One, perfect orientation. The metals have to be perfectly oriented. The circuits are organized via the proteins, even though we focus on iron sulfur centers and hemes. It's the proteins that order them perfectly. And the other thing, of course, is that wherever there is a transfer, there's catalysis. And most of the enzymes in the world are proteins. So for all of that, this is only possible due to all those proteins. I'd like to thank my TA, Swing Suda.